Welcome everyone. I'm very happy to be here in the Learning Fest. I'm Daniel. Um, I want to thank all the Factor team behind the Learning Fest because this is a great opportunity for everyone, for me to keep growing as a presenter, and for you to know more about Factor. Maybe in the future you can join Factor as well, and you can start working with us. So today we are going to see this talk called Calling Python Law with Dask. So the main topic of today is Dask. We are going to see what Dask is. So yeah, this is the agenda for today. Why should you attend this meeting? I'm going to answer that in the first place. After that, you will see you will know a little bit about me. And today we are going to see a story about a data engineer called Pip. So Pip is a fictional data engineer that I like to use in my talks. So today, with that story, we are going to learn what Dask is, what it does, and why you should use it. And at the end, as Berto said, we will have a Q&A section. So why should you be here? So today, more than the text, of course, you will finish this meeting knowing a little bit more, something new of Python. But the most important thing today is that you will see a story of an engineer. So I hope that you enjoy this story and you have some insights from that story. So first of all, I present myself again. So yeah, again, I'm Daniel. I'm a data engineer here at Factor. I have been at Factor like for a year. If I try to define myself by the things that I like, so saying that I can be a chess player, a hiker, a cyclist, an actor, but above everything else, my main occupation is as a Python developer. So 9.9999% of my time I'm working with Python and reading code in Python and writing code in Python. I have been work in several applications for web development, data analysis, machine learning, data engineering, some artificial intelligence, all of that with Python, because Python, I believe, is the best language out there because it's very flexible and because it has a very great community. So you can start learning Python in an easy way and you have a lot of material. So today we are going to see the story of Pip. Pip is a fictional character from a book called Great Expectations. If you read that book, you will see that Pip had a tough life, but at the end, he managed to be okay, just okay. Now, today, we are going to use it as a fictional data engineer. Today, he is a very successful engineer, but not always was like that. He has an origin story where Dask was one of his tools to help him in his journey. And this journey started because he fell in love with programming. So he really loves programming, and now he has Dask in his pocket. So he's going to go outside and show everyone his abilities. However, after 9 years of hard studying and researching on electronics, this engineer kind of hits the reality. He noticed that maybe in order to achieve the things, some of the things he wants, he needs money, like food, rent, clothes. But there is a wall behind he and the money. So he wants to climb out that wall. So he realized that maybe in his country, the market wasn't kind of in the way he thought. Maybe his knowledge is not kind of in demand, his main knowledge. However, for him, he's very lucky because through his life, he had many interests, very different interests, like programming, math. He really liked to keep learning new things. So that is a great thing for him because he is able to switch paths, to be flexible if necessary. If he noticed that something is not working well in the way that's working, so he needs to change his mind and start learning new things and overcome that wall. So yeah, that was the solution. The solution for that is to keep learning. That's the only possible solution, to keep learning. And with these new tools, he will start doing different things. However, in the meantime, he continues applying to other jobs, and maybe the recruiters are not so kind of smart. Hey, not hidden factor. Hidden factor is different, but maybe most of the recruiters doesn't know who they have in front of them, so he encounters a lot of rejection, but that doesn't matter. He continues learning, and in that learning path he knows Python tools like NumPy for computing, for Matplotlib for drawing new plots, pandas to handle data, and Seaborn to make more beautiful plots than Matplotlib, and scikit-learn to do some machine learning. So he continues studying. So he found this Python ecosystem is very good, the open source mentality, because allows everyone to keep learning and keep trying, and you don't need you only need an internet connection and you can start learning. So at given point, he realized he can't just keep learning and learning, but he need to start doing. So he decided to join a hackathon. So a hackathon is just a contest where a bunch of people reunite and start coding in order to solve a problem. So in this case, he joins a hackathon with the hope that maybe he can win or something, and he can start putting more to show the world what he is capable of. So he joined this hackathon. He has these tools, NumPy, Matplotlib, Panda, Seaborn, scikit-learn in his pocket. So he wants to do the best he can. So with this in mind, let's see some of the codes that Pip developed. So today we are going to use this data set. This is not the same data set that Pip used, because Pip is not allowed to share that data set. But in here we have this data set where we have books from Amazon. So we have two tables, one for the book details. That means having the title of the book, the description, the authors, and so on. And for each book, we can have many reviews for different customers. And so each customer will give a review. In here today, we are only care about the string columns, so the text columns, so like title, description, and review, for example, those. So let's try with pandas. I don't know if you already know pandas, but pandas allows you to handle this kind of problems. So in this problem, the hackathon was about to get this data set and try to get some insight from that data set. And with that, try to run a prediction. I don't know, maybe by given title and genre, kind of predict if it's going to be well received by the reviewers or something like that. It can be many things, but today we are going to focus in the first part of the process, that is the pre-processing step. So what Pip has in mind is to use some natural language processing to process that data. Doesn't kind of be afraid of this. We are not going, this is not a talk about natural language processing, so you can kind of don't pay attention to this. In here we are just getting, you can see a function here that is going to process this text, but doesn't really interesting here. So yeah, he loads the data. He noticed that how many books he has, how much memory it uses in this process. It does the same for the other data set. In here, we have a lot of more data. We have more here. So that's a lot of data. He gives a quick look at the data set. So the title, description, and so on. So a lot of text columns. And so a good practice for you is to always check out how the data types are, because if maybe you notice that, for example, this column is a categorical column, you can change that data type and save some memory. But today our focus is not on that. So we are going to use just these types, data types, the same for the other table. So the heavy part of computation here is this function, but this function does is to extract lexical token. What is a lexical token? Is just a word or symbol that carry meaning. So for example, if you have this example text here and you run this function, you will get this result. Don't pay attention too much to the ideas behind here, that is natural language processing. Just see that this is a very heavy function that we are going to run for each row in our data set. Just have that in mind. And that this function is complicated enough that you can kind of replace it for some other abstraction from pandas. You have to use this custom function here and use the apply method from pandas. So let me show you that. So remember, how many books do we have? We have a lot of books. A good practice is to start your analysis with a subsample of your data set, so you can start playing around with that without kind of losing time. And in here, what we are doing is getting an amount of books, merging both tables to get these columns, the review, the title, description, authors. We are joining using the title because the data set is how it is. Maybe that is not the best. Maybe a best approach was to kind of get a hash key from the titles and using that hash key to join. But remember that today we are not going to see the best solution. We are going to see the solution that people use to be able to give a good result. Remember that this is a hackathon, so there is a constraint of time. So you can't keep iterating, finding the best and best solution. And that's something that you must remember always, because it doesn't matter if you have the best solution. What matters if your solution gives value in some way. So the value is the real thing that you must optimize. So in this case, Pip wants to try to iterate and use kind of something good enough to give him good enough results in terms of computing execution. So that's why he tried, first of all, with this ugly function here, the apply. So if we see here, we have a recipe. So we get the data frame, this data set from pandas, that is the one that is after the merge of the two data sets. And we create a new column text that is just the concatenation of all the string columns. We make sure that pandas understand that as a string type. We select that new column in here. So we, instead of having a pandas data frame, we have a panda series of strings, and we can apply some string manipulation on it. And after we have that, we apply this function. Actually, is not a good practice to use the apply function because it's very slow, but in this case was the only option because he didn't want to rewrite this function but keep it in here. So apply is an option to do, but it's not very performant, as you may see, because for running for 1000 rows, 1000 books, sorry, that doesn't mean rows, because after the join here, after the merge, since each book can have many reviews, you can end up with having a lot of rows in that data set. So I noticed that he is running 23 minutes. He is not even close to running the whole data sets because it's only 1000 books. So that's very disappointing for him because he needs to process as many data he can. So this is not optimal. This is not even good. I remember that we are not looking for the best solution, but this solution is not good enough. So he started thinking and start seeing, okay, I have this computer, my laptop, I'm working on my computer, but however, I noticed that I'm not using the full capacity of my computer. So that's something that maybe I can resolve. Well, why not trying something different? And that's how he goes back and notice that he has a problem. Usually, if you have a big data set, maybe one solution for you is to go into the cloud, you pay a cloud provider, and you, I don't know, you start a PySpark, a Spark cluster or something like that, or using Athena with Blue Jobs, or using a Snowflake or whatever. But in order to do that, you need to pay. And the problem was that he was financially broke. He didn't have money, and he only had his laptop, but even his laptop wasn't working properly. The charger was working badly, so the processor of his laptop was working on under frequency, so it was madness. So he had no choice but keep using his laptop as it is and try to solve in some way this problem that is enough for him. So remembers something that teachers tell him some time ago, that is, what is an engineer? An engineer is just a person that does the same other thing as any other person, but cheaper. So in this case, cheaper for him was kind of keep using his laptop as it is and don't go into the cloud and that kind of thing. So he encounters Dask. What is Dask? Dask was the solution, was one of the solutions. What is Dask? Dask is a flexible general purpose library for parallel computing. As you saw, as Pip noticed, he wasn't using the full capacity of his computer. You saw that CPU utilization for all the cores kind of in the half. So maybe that was a good option to get the best of his laptop. The good thing about Dask is that it's Python based, and since Pip kind of is a very good Python engineer because that's what he chose to learn, that's a very choose for him to keep using Dask. And Dask stands for scales, NumPy, Pandas, and scikit-learn that are the mainly used tools in the Python ecosystem. So that's great because he already knew how to use Pandas. So maybe using Dask could be easy for him. Dask can be deployed in a single node. In a single node, that means like in a one core in your machine or many cores in your machine, and you can scale up out of the cluster. That means many machines in a cloud, I don't know, in a Kubernetes cluster or something like that. We will see that at the end. And even it supports GPU acceleration. So if you have a GPU in your laptop or your computer, you can use that GPU to accelerate your computation using Dask. So let's see some code. So Dask has several abstractions. One of the abstraction is Dask data frames. So the idea behind Dask data frames is that you have the same as you have in Pandas, but you have it in parallel. So he, instead of importing Pandas, he import Dask. This is the same. Now he must create a client. A client is just the cluster in your local machine in this case, because it's a local cluster. So it will give you a dashboard, and in this dashboard you will see the utilization of your workers. And in here by default he will launch as many workers as you have. In this case I have a computer with 4 cores with 2 logical cores between that, so that means 8 threads. So yeah, that's the default. And now he, instead of using Pandas, he used Dask to read the data. And he noticed that, okay, I went to see how my data is. He noticed that everything is empty. So what's happening here? What's happening is that now he's not having a Pandas data frame, but instead a Dask data frame. And for Dask, these are delayed objects. That means that is going to be evaluated in a lazy way. So that means that it only get materialized when you need, not before. So in here, we are not running any computation in here. So that's why this is kind of empty. And that's the same for the other data set. This is the same function as before. And don't think about that. This is the same. So in here, a good practice is to materialize what strategically. So in here was a good option to materialize the first 100 books. And after you materialize that, you get a Pandas data frame. So in here, instead of merging 2 Pandas data frames, now we are going to materialize Dask data frame. That is the same as saying a Pandas data frame with this Dask data frame. In here we merge. This is exactly the same. So if you notice, the only thing that he need to change was the import. So that's pretty cool. And in here, actually, it's pretty fast. Why is that fast? Because in here, we are not running any computation. In here, we are building DAG, a directed acyclic graph for Dask, that will tell later how to compute your data. So in here, we're just kind of making the recipe and creating the DAG, and now we can materialize it. So to materialize it, the thing that you will need to do is use the compute operator. So after he runs that, he noticed that now his time is 18 minutes. So now if he go and see the CPU usage, now he's using his computer, but he's not achieving too much better results. So what's happening? So he goes and see the Dask UI and see the CPU utilization by core. So everything seems kind of balanced here, but after some time, he noticed that only one worker was doing all the job. So that's why it was taking so much time. Maybe at the beginning, you split the data, you do the compute, but after that, you need of to rebuild that data frame in memory, and that's only possible with one core. So it takes a lot of time doing that here, taking back the data. So you see, it's only using at the end one core, one worker of 4. So that's kind of disappointing for him. So he thinks, okay, maybe Dask has another kind of abstraction to work with. So that's true. Dask has another abstraction that is the Dask bags. You can see this abstraction as a way to kind of have an iterator, and within that iterator you can iterable object. You can have this function, you can map, you can filter, you can fold, generate Python objects. So if you have worked with PySpark before, this is similar to the RDDs. So people now wants to try with this abstraction with the Dask bag. So he now import the Dask bag, and this is the same. So he creates a new plane, he loads the data, and he builds this function here, he perceives some data. And the difference here is that this recipe is now going to the back from sequence that is going to take a sequence and create a bag. And after that, after you have a bag here, you can use this map to iterate over this function, over this sequence using this function. So that's similar to what he was doing before, but with a different abstraction. And he materialized with compute. Now, instead of waiting 18 minutes, he waits around of 5, 6 minutes. That's pretty good, actually. It's not, as I already mentioned, is not the best. Maybe a best possible solution is to use a different kind of abstraction to kind of vectorize your compute and using the GPU, but yeah, that's beyond the today. But yeah, this is pretty good for him because he can process a lot of data and without waiting too much. So it's kind of successful because if he goes and see the course utilization, now he see that with this abstraction, he's using in a more proportional way all his compute. So yeah, he's very happy. He runs for everything. And after that, he has all his data classified, not classified, processed. In here, why this is best as the Dask data frame? Maybe because when you have this kind of problem, when you have this hard function here, and you are not using kind of native functions from pandas, for example, like I don't know, lower of apply or group by or whatever, but you have a custom function here. A better option than Dask data frame is to use the Dask bag that allows you to run these kind of processes. So that's good. Pip is very happy because he was able to process the data. And thanks to that, he was able to not to win the hackathon, but he kind of was at the podium. So he received one of those big checks, fancy checks that are kind of, I don't know, those big checks that you put in your wall. And he has all the fuss, and he was in a YouTube video, and everyone was kind of happy. So that helped him to kind of brag on LinkedIn a little bit, and now recruiters now kind of pay attention to Pip. That was great. That was a success, even though it wasn't the best solution. He didn't win. But was good enough to land in a big company. Now Pip is kind of in that change of path after studying a lot of electronics. Now he's in the right path because he's doing things that he likes, and not more important, but important enough, he makes money out of that. So that's very important because he needs to eat and buy clothes and that kind of things. So yeah. So he lands in a big company. One day in that big company, they have a process, a very long running process. In this process, a lot of computation was, maybe not a lot. This process was just a serial query process. What do I mean by serial query process? It's a process where you use, in this case, Python to build a query, a SQL query, and put that query into a database. So you build the query, you use Python, a Python connector for MySQL, for Postgres, whatever, and you put that into the database. So all the compute is handled by the database. However, the databases doesn't work in parallel for a single query. So they kind of want to, all the cores they have, kind of distribute those cores for many requests that many users can give them. So one day, looking at that process, something fell, and they were kind of, oh, the whole team sitting around waiting for that process to finish. So they were kind of, oh, why don't this is better? Why do we need to wait too much time to this to finish? So people goes and see the CPU usage for the server, and he noticed that only one core is being used. So he remembers Dask. So maybe we can do something to make this process parallelizable. So why don't give a Dask a try? So let's see some code for that. So Dask has another abstraction that is Dask delayed. With Dask delayed, you can delay objects of Python, as the name says. So in a way that, as I showed you, that when you load, for example, that CSV file, you kind of don't get the data now, but only when you persist the data or you run the computer. So it is evaluated in a lazily way. So I'm going to give you a really quick example of how that delayed works. So you see here this simple function that I have here is a very silly function because it just when this function runs, it is going to sleep for 1 second, and after that return a string. That's it, nothing very interesting. So if we create a list using that function and we run it, it will wait 1 second for each item of that list. In this case, we have 5 items, so that means that we are going to wait for 5 seconds. But what happens if I try to run that in parallel? So instead of having my simple function, I have this exactly the same function. The only thing that is different here is that I changed the name just to make it different, and I added this decorator. This is the decorator that I have imported from Dask. So Dask has this delayed function here that can be used as a decorator. So in a way that this is now a lazily function, so it's only get evaluated in compute. So he built the same list as before. Now he must run the compute function here to persist that data, to materialize that data. And he noticed now that instead of waiting for 5 seconds, we are going to wait just by 1 because we are running those in parallel. So that's pretty amazing, because if you notice, you can take your previous Python code that has been running in your source code for many years, add this delayed operator, and maybe you can gain some speed. So this is what Pip saw one afternoon. After a long day of fixing bugs, he runs everything and he noticed that this server is not working at full capacity. So that's an issue that maybe he can resolve. And as I already mentioned, the use case was something like this. So he has a Python source code. This Python source code builds a SQL query, put that query, create that query with parameters and sends it to the database, but the database is only using one core for that query because the other cores are reserved for other requests. So he kind of ask for the help of the database administrator to see if maybe there is some configuration there, then maybe they can put in place to make the database to use more cores or something like that. But sometimes the DBAs are kind of busy or they don't want to help. So he wants to take to be in charge of his process. So he thinks that maybe a tricky way to resolve this is to take that query, put an additional parameter there in a way that the database will get a section of the other tables involved in the computations. And maybe we can send several queries in parallel. So the database will kind of understand that this is coming from different users, and he will use a core for each one. So we are not using the full power of a cluster here using Dask. We are using kind of a very easy to work with abstraction that is delayed, but is getting some value. Remember that here, what is important is the value that you get, not the technology or how you do that, but the value. Of course, you must write good software to make things scalable and that kind of things. But in the first place, always is the value that you are adding to your business. So yeah, the idea is as follows. In here, I'm using a toy example, so don't worry too much about this. I'm using DuckDB, that is kind of an in-memory database that allows me to run some queries here without creating a database like Postgres or MySQL or whatever. So this is a toy example. You don't worry about understanding this. This doesn't matter today. What matters is that you have a table. You have two tables actually. In this table, you have a date column and a metric column. So you can see that, I don't know, you are measuring something, you're measuring the temperature or something like that. I don't know, the stock value of something by day. So you have the metric in this table that is called dates. And you have another table called analytics that you want kind of aggregate the result of that metric by month. So you want to kind of take all the data from January and add it up and get the average, for example. I don't know. And the problem, also another problem that I didn't mention is that this database was a transactional database, so it's not the best for analytical operation because it's a raw database, not a columnar database. So that's also make the whole process very slow. So as already mentioned, changing from a raw oriented database to a columnar database maybe wasn't achievable at that time because the company was a very bureaucratic company. So changing everything was kind of a hard pain. So yeah, he is not on the table. So remember that we are not looking for the best solution possible, but for a solution good enough that gives us value. So with having that in mind, he kind of, this is an example of the query that I was talking about to get the metrics. So we are going to put that into the serial metrics. So this is a normal SQL query. The solution, the proposal solution is to use a similar query here, but with an additional filter in a way that each of the subqueries are going to take just a, a range of data, and each query will be processed in parallel for that range of data. So in this case, for example, we are getting only the months of June and July in here, these dates, using this filter, and we get the metric. So we can parallelize that. Instead of having that, we can create a function with the delayed operation. So in a way, he receives the months that are going to run for that partition. We can create each partition by month. This is a silly example, but in essence, was what people did at that time in that company, in that big company, in a process that was taking 8 hours, using this delayed, this very silly thing in here, he was able to achieve kind of by half the reduction. So instead of waiting for 8 hours, it was kind of 3 hours or so. So that was a huge success. So it's for him. So in here we create, as in the example, we create that list with the delayed objects. And we have the delayed objects here, and we run compute. So this is going to run in parallel, these things for each partition. And after that, we can put that into the parallel analytics and compare with the serial analytics and get the same data. So that was a huge, huge success for him because he was kind of the hero of the company. And he was thinking, well, this is very, very hacky because I'm not kind of optimizing anything in the database or something like that. I'm just kind of making a trick on the database. So, but yeah, that was a huge success for him. So that was very happy for him, and everyone was happy, and he received a huge bonus for that. So yeah, remember that the most important thing is the value that you can bring to the table. So now Pip is happy because Dask has delivered him a lot of good things. So he may keep working with Dask in the future. And the dream of Pip is that he one day will build a cluster like that. When you see these delayed objects being computed, being materialized in parallel in a big cluster. So this is what is next for him. I hope that that kind of makes real in the future. So yeah,
Danny,
uh,
uh,
yes.
we are getting into the last 10 minutes. We have some
Mhm.
questions about Spark. Perhaps you're going to address
In few
in the
slides.
slides.
So yeah, I'm close to the end. Thank you, Berto. And so yeah, after seeing this story, this beautiful story, now Pip is very happy. He has a good life. He's able to sing, to dance, to travel. So yeah, just by keeping learning Python tools. So yeah, you can use Dask in production as a single machine, as I showed you today. Maybe if you don't have a shitty computer like like Pip, but you have a very good computer, so maybe it's a good idea to work with Dask in your local environment, but also you can go and distribute your compute. You can run Dask in a high performance compute environments like using MPI. You can build a cluster with Kubernetes and deploy there. You can even use Yarn clusters. And of course, you can deploy this in any public cloud. They have, okay, that's the next slide. These new options that they are you have to pay to use this function, these tools, these platforms, but are a very good option if you want to deploy your Dask application in the cloud. So you have this coiled company that allows you to use AWS, Azure, GCP, whatever, into for your Dask application. So that's very good because it's fully managed. So you don't need to care about many configuration steps. So it's something that if you are interested, you can check it out. They have a free trial, so you can check it out. And there is another these other two companies that I don't know too much, but yeah, it's a similar option as Coiled. And the good thing about Coiled that is maintained by the same team that created Dask. So that's good to know. And you may, if you have worked before with another tool for parallel processing that is Spark, you may be thinking, well, what could be the difference? And the main difference is that Dask is Python native. So the main difference is that Dask is Python native. So if you are a very good Python engineer and you have a lot of experience with Python and you really like the syntaxes of Python and his flexibility, you might not want to see some Java code if you get an error or something. So Dask is a good option for you. Uh, Spark is Scala and Java Virtual Machine environment based with Python bindings, PySpark, I mean, and not Spark by itself. If you use PySpark, that is kind of a package of Python that allows you to use Spark behind. Um, a thing to know is that Dask, on the contrary of PySpark, for example, doesn't allow you to write SQL queries. That means that you have your data frame, your Dask or Spark data frame in this case, and you can select the data using a SQL query. Spark has that ability, Dask doesn't have that. However, there are some packages like Dask SQL and Figure that kind of try to add that support to Dask, so you can check it out. Spark, as you may know, is kind of the widely used tool in industry. A lot of people is using Scar because it arrived later. Before Dask is widely used, so a lot of people is using. it works pretty well. I have write some applications with PySpark, for example, and it was great. It had huge success with the Spark as well. So yeah, it's something good. Dask is newer, so that's maybe why it's not widely used yet. But if you do a quick search, you will notice that Dask is getting more and more attention, mainly because of the Python community. If you have a tool that kind of is in sync with all the Python ecosystem, that will give you a lot of possibilities in a community. Spark uses the map shuffle reduce paradigm. If you know about that, is that kind of you kind of write your function in a way that you distribute, uh, run a function in each node, and after that you run a full aggregation operation over the results of those nodes. That's the paradigm. Dask is more kind of a generic task scheduling, so it kind of send data to each one and kind of organize the way they compute, and it's very similar, but it's a different paradigm. If you want to know more about how Dask is different from Spark, you can check this link around here. So yeah, that's the end. And
Great.
since we are in the end, I have a confession to make to everyone. And the truth is that the PIP is not so fictional. Actually, I am PIP. So yeah, uh, let's go for the questions.
Great. Thanks, Danny. Amazing talk. We have a few questions. Probably we won't address all, and we will write down the answer later. You talk already about Spark. There is many people asking to share a repository and courses where to learn about Dask. If you can share some links in the chat or later, great.
Of course.
People love the conference. There is a very specific question here. Can Marcos Herrera is asking, can I run modding on top of Dask to get 100% coverage of pandas? Do you know?
Okay, yes, I have heard about modding. I think they use Dask. I haven't tried modding actually. I don't know if they are kind of get more usages of out of pandas. Actually, I think you can. Yes, I need to check, but yeah, definitely modding is an alternative. Another alternative that I remember for parallel processing using Python is Ray. Ray is a new one. It doesn't use Dask, I believe. But yeah, I believe that modding use Dask. If I'm wrong, sorry. But yeah, I doesn't have the complete answer for that. Sorry.
Great. We have to get to an end because there are talks after this. I will share the agenda. Keep an eye on the agenda. There are very nice talks today too. And I just want to thank you, Danny. The talk was great. People love it, and I'm honored to join you here as a host.
Thank you.